Assalamu alaikum. In today's lesson, we shall discuss some past paper questions related to vectors. So, in the last lesson, we discussed about the cross product and the triple products. So, today, here are a few questions. Now, look at this. The vector, this is vector A and vector B. We have to find the magnitude of A dot B, and the projection of A on B. Now you can see from here, I can write this vector in this form in vector notation. Magnitude is simply x component square, y component square, and z component square, and its square root. Similarly for b, so we have a square root, a magnitude, and we have this b magnitude. A dot b is simply the product of their corresponding components, x into x, y into y, and z into z. So as a result, we get this A dot B is equal to minus 6. Now, the projection of B in the direction of A. For example, if we say that this is our vector A and this is our vector B, so projection of B in the direction of A can be considered like this. For example, let us extend this vector A over here. So we extend this vector A, right? This is vector A, and now let's draw another line. Now this is the projection of B in the direction of A. If we draw a perpendicular line from there, so this is projection of B in the direction of A. See this one. Projection of B, this is vector B, projection of B in the direction of A. B means the horizontal component of B in the direction of A. Now you can see that if this is, if we find out B cos of theta, now this is horizontal component of vector B, which can be actually written as B cos of theta. So B cos of theta, we can again use simple concept of A dot B equal to AB cos theta. So divided by, we have done this A dot B over here, and divided by a magnitude will give us the component of B in the direction of A, or projection of B in the direction of A. And from the diagram you can see that B, this component of B is actually opposite to A. That's why there is a negative sign. Or you can say that this angle is greater than 190 degree. It seems to be, you can see over here, this is greater than 90 degree, so that's why the cos would be negative. In second question, you can see that A cross B cross C can be written like this. Now in order to do that, I have get this. There are different ways to prove it, but over here this one is easier. That if we consider that the A vector is only a component, B vector has two components, C vector has three components. Now let's do it in this way. It's slightly different from that one, but even then you can modify it in that way. You can apply the same technique to solve it in this part as well. Now when we solve it, so this is A cross B and this is C. A cross B is only this component, and means that when we open the determinant we have only k component. When we multiply this k component with the C vector, so this k cross k would be 0, and we shall get only j and I component from here. Now similarly, if we have the if we solve the right hand side of this equation like this, write the components, component of A dot C, and this is B, and similarly this is B dot C, and this is vector A. And after simplification you can see that over here this part and this part, the equation 1 and 2 are exactly same, so it means A cross B cross C can be written like this, right? Okay, you need a practice to solve this. In this question, what value of A the vector a and b are perpendicular. When two vectors are perpendicular, it means we can write them a, their dot product is 0, right? So take the dot product, x into x, y into y, z into z component, put it equal to 0. After solving this equation, we get a equal to 3. Okay. Now this question, we are given three vectors, a, b cross c. So this is a, this is b cross c. Simply we write b vector, c vector components and open the determinant, and as a result this is b cross c. Now there is a dot product over here, x into x, y into y, z into z. Solving that, we shall get 52. Similarly, a cross b cross c, now we have to prove it. We do not need to we do not need to prove it, we have to solve it. We have to evaluate its value. So simply write the values of a, b and c. So this way, even you can do it in another way. For example, you substitute the values of b and c and then take the cross product, then take the cross product with a. Otherwise, you can use this equation, convert the cross product into the dot product, and then now this one is the a dot c, this is just a number. Similarly over here, this is a dot b, this is just a number, and after solving these two, we shall get this answer. This is a vector because the triple vector product is actually a vector, so we get this answer. If you substitute the value of b and c over here and take first you take the cross product, then you take the cross product of the resultant with a, again you will get the same answer. I hope you understand. If you have any further question, you can write in the comments. Thank you.